today's video has some goals about using our graphing calculator to make some graphs of parabolas and other quadratic functions, and also just some general features which are great. So the first thing we're going to look at right away is how we can make fractions, and we're going to use the first example in your notes to do that. So the first thing we have to do is make a graph of this and identify these features, and it gives us a function up here. Now the first thing to note is that in our graphing calculator, it only does y values. It doesn't use function notation. So f of x is just the output. We know that whatever x value we put in, we're going to get something out of it by using the rule to the right. Our calculator calls that y, right? The output value is just y. So when we see function notation, it's okay to replace it with y equals. Now for a fraction, there's two ways we can do it. The first way is just to use parentheses and then use the divided by sign for the fraction bar. So when we type in an equation, of course, we put it in y equals. It's always appropriate right now to make sure your plots are not on. So like one that's highlighted is on, and I don't want to use any scatter plots right now, so make sure they're all off. So the first thing we can do to type in this equation is put a parenthesis for our first fraction, and then 1, and instead of the fraction bar, we do the divided sign, and then the denominator is 2. We then close our fraction, and we type the rest of the equation. X squared minus 4x plus 5. So that's one way to do it. It will work on every single calculator. Other calculators, though, are slightly newer and do have some built-in features. So I'll show the key press history on this. I'll copy it over, and then you should be able to see it here. So if I wanted to actually format the fraction that looks like a fraction, I can hit the alpha button, and then above y1 in green is f1. So since I've hit the alpha, I've activated the green commands. So I want to hit f1 up here, so I hit the y equals button. And you'll notice that option 1 looks like a fraction, n divided by d. So if I hit option 1, which I'm just going to take a picture of this to put in the notes so it can stay there for you, is it gives me the top and the bottom of a fraction. So if I go back to my function, I can just type in the 1 on top, 2 on the bottom, and then the x squared minus 4x plus 5. So no matter how you type it in, it doesn't matter. For you, just have 1 in your calculator, so I'm going to go ahead and just get rid of the first one just because I chose to do that. It doesn't matter which one you have. Now, what we're going to do next to make a graph is we have to go see the graph. Before we do that, we usually want to take care of our window. The best window to start with is -10 to 10 on both the x and the y axis. And there's a built-in button for that. We can hit zoom and then choose the standard zoom for 6. So since this is quadratic, we should see a U-shaped graph coming in, and I ask that we sketch it over here in our notes. So I'm going to make mine red just like that one is red. So over here it looks, and we'll just be somewhat specific, it doesn't need to be perfect, but it looks something like that. So that's our parabola. So the first thing we want to be able to do with the parabola is find the vertex. Now in our notes, when we're finding a vertex of a parabola, we do know that the vertex could be the highest point or the lowest point. So like on our parabola, what we see is that it's the lowest point. So I'm just typing that in. So the lowest point of a parabola, we just have to keep that in mind because the lowest point, another word for that lowest point, is the minimum value. Now why do we care about that? Because when we go to our calculator, we need to know the difference. So to find the vertex of a parabola, we're going to hit the second button. And second is blue, so we've activated the blue commands. And we want to calculate the vertex, so we're going to hit this button right here. And it does depend what your vertex is. If it's a minimum, we need to choose minimum. If it's a maximum, we need to choose maximum. So here it's a minimum, so I'm going to choose option 3. So this is the button presses to always get you to that. You can write that in your notes however you so choose. Now it's going to ask us a bunch of questions, and I already have those in your notes for you, but the questions it's going to ask you is the left bound, the right bound, and then a guess. So in other words, the calculator doesn't want to check every single x value to find the x value of the vertex. It'd rather just have you narrow down its search. So I always start with my cursor on the vertex. So if it wants to know where's a little bit left to there, so it wants a left boundary. So I go to the left. So when I hit enter on my calculator, it gives me a dotted line. Some of your calculators might just put that triangle. But this is a boundary to the left-hand side of my vertex. I'm telling the calculator, don't look anywhere past here. It's not going to be there. So I've narrowed down the domain, or the amount of x values that it needs to search for. It wants me to put a boundary on the right-hand side too. So I'm just going to move my cursor a little bit right past the vertex and say, hey, don't search past here. If you go further right than here, you're not going to find it. The last question it wants to know is, where do you think it is? Just put me really, really, really close to it. So we've told the calculator it's somewhere in between here, and we think it's right there. And it'll do all the rest of the work to find the exact value. So then I hit enter to that. Now, it'll tell me the minimum once it says minimum, and sometimes it has some problems rounding. Like this number is clearly supposed to be 4, and for some reason the calculator only did that at 4.000001. On assessments and stuff, for me, just write down whatever you get, and you will never be wrong. But in some cases like that, you could plan ahead and say, well, I really think that's the point for -3. If you're concerned in class, you could just ask me or ask your teacher. Now, we'll have an example later where that vertex is a maximum value, but essentially it'll be the same. But we can see here that our vertex is a minimum value, and it happens at the point 4, -3. So now we need to find our x-intercepts, which are also called the roots, which are also called the zeros. And I can see here there's 2 of them. Now, in our calculator, a few things to note is that we have to find each one separately. If there's 2 of them, we have to do this process twice. So to find the x-intercept, or the roots, which are also called the zeros, again, I'm going to hit the second button, which activates all the blue commands of these buttons. I want to calculate something again. And this is why we need to know our synonyms, because it actually calls it the 0. So for the 0, I'm going to choose option 2. So just copying that into our notes so you can go back and see the buttons if you need it. So those are the buttons that you will take to get to the 0. Now, just like when we found our vertex, it's going to ask us some questions that are very similar. It wants to narrow down the search. There's so many x values on this graph, it doesn't want to search through all of them to find that one x value, or maybe 2, where the y value is 0. So just like the vertex, we're going to start our cursor on the one that we want to find. And then to narrow down our search for the calculator, it wants a left boundary. So I just go left a little bit, and I say, hey calculator, don't look past this point on the left. And the same thing for the right. Don't look past this on the right. And just to help you out even more, it should be really close to this number. This point right here should be the 0. When I hit enter, it gives me that 0. And again, it's best practice just to write down whatever the calculator gives you. So 1.5505103 is the x value. And I'll just round that to 2 decimal places right now for our video. And the y value is 0. So that's the first x-intercept. Now to find the other one, we just have to repeat that process again. So we hit the second button, the calculate button, which is here. We want to find a 0, which is the x-intercept. But on this one, I need to give it different directions because we're finding a different x-intercept, or 0, if you will. So I start with it on, and I go left a little bit. Don't look left past this. It's not going to be there. And then go a little bit to the right. It's no further right than this. And to help you out even more, it should be really close to this point. And it does tell me the coordinates there of 6.45, and the y value is 0. Now again, here we see some really weird rounding. For the x-intercept, the y value has to be 0. And this number here is 0.00000000001. So it's supposed to round it, but for some reason it didn't. You'll notice your calculator does that sometimes. Sometimes it doesn't. There's really no rhyme or reason to it. So if you ever have questions, just ask your teacher how many decimals you should write down. So we found the x-intercepts. Next thing we're going to do is find the y-intercept of a parabola. Now, what's really easy about the y-intercept of the parabola, we know it's always the point 0, y. In other words, x is always 0. So on our calculator, what we're going to do, if you haven't seen this pattern yet, we're going to go back to this second tracer, the calculate menu. But what we can do now is we can tell our calculator a value for x, and it'll just tell us the y value. So if I choose option 1, just adding these to the notes. When I choose option 1, it asks, well, what x value do you want to plug in? Well, if I want to find the y-intercept, the x value has to be 0. So I just type in 0. And it tells me the y value is 5. Now I could see that probably from the equation, but not all equations will be that easy. So the y-intercept is 0, 5. Oops, got a little typo there. So I'm just putting that in 2 places on our notes. Now with that though, that's also the thing below it on our notes. I don't have to do that just for the x value of 0. I could do that for any x-y pair. So if I go to second, calculate, and let's say the value that I want to do is something like 3. So if x was 3, what's its y value? -5/2. If I plugged in the x value of -0.123, the y value there would be 5.499, whatever. Now, the one thing I do want you to notice here is like when I typed some stuff in, like for instance, if I typed in 3, it gave me the answer as a fraction, -5/2. And that fraction matches how I typed my fraction in. So you'll notice that if I didn't use that fancy fraction button, if instead I just used the parenthesis method, the 1 divided by 2, I still get the same graph. Everything is going to be the same, but I will notice that the calculator will give me an answer that doesn't use that fancy fraction formatting. Because I didn't use the fancy fraction formatting, it will not either. So let's go see how it does that. So again, if I put in 3, last time I got like a fraction, -5/2, but now it just gives it to me as a decimal. So our last example for today is just another example here. And what we notice about this parabola is it's in a weird form. We're not really super used to this. It's called vertex form. We're going to see that later in our chapter. But it's good to do right now because we don't know how to work with it, but we can still find all these things. Let's go ahead and type it in. So I'm going to use the fraction method. So -5/4. And then we have parentheses x minus 3 and another parentheses squared. Now my window is the same, but it's always a good habit to start with that zoom 6. And then we're going to draw the parabola on our notes. Mine is coming in orange here. And again, just be as accurate as you can right now. So it's something like that. Now just to touch base again on our vertex, this is what we can clearly see here is that vertex is a maximum value. So when we're trying to find the vertex that's a maximum value, like we saw in our notes, we just have to choose a different option. So again, we're going to go to second and calculate. But this time our vertex is a maximum, so we have to hit option 4 instead of option 3. So not significantly different, but just got to be aware that those are two different features. So then we go through the questions. I'm going to start with my cursor on the x, or on the vertex. Now I want you to see, like on here, I can't see my cursor. I don't know where it is, but it'll always give you the coordinates of where it is. So if it's in a negative y value, it's down here somewhere. So I want my x value to be positive. So if you ever lose it, you can go find it. So here's my vertex. I think, so I have to go to the left a little bit. So calculator, don't look past here. To the right, don't look past here. And to help you out, I think it's right in the middle there. Now something like this, 2.99999, again, you might not be sure if that's supposed to be rounded up to 3 or not. In this case, it is. If you're ever unsure, just ask your teacher. And again, sometimes your calculator will do that and sometimes it won't. And notice that number really small. I just rounded that back up to 0. Now when it comes to this one, the x-intercepts and the roots, like where does it touch the x-axis? That's the same thing as the vertex. I don't need to recalculate that. I already know that point right there is 3, 0. And that's the only place it touches the x-axis. So finding the y-intercept, I can't really see it in this equation. So we're going to go back and we're going to find the y-intercept using the method we outlined here, which we're just going to use the value function. Just got to tell the calculator x is equal to 0. So second, calculate. The value for x that I want to plug in is 0. So if I plugged in 0, I would get -45/4. So that's somewhere down here. Now, just again, so we can practice that feature, it doesn't have to be the x value of 0. We could have our calculator calculate any xy value. So let's say I want to plug in the value of 6. I also get -45/4. So that'd be like, well, 3, 4, 5, 6, or somewhere like over here. That would also be the same value of -45/4. Which is a pretty interesting feature to see. We kind of see some of that symmetry there. Notice how they're kind of the same distance away from the axis of symmetry. But again, your responsibilities for today is making sure you know how to use your calculator to do this stuff. So you might need to watch the video once or twice. You might need to do a few examples, slow it down, so on and so forth. But make sure you know where these buttons are and how to use them.